starting into Module 6. You may have noticed we did skip 6.1, so we are starting into 6.2. For this week, we are going to be working on using those same ratios and rates that we have been practicing from Module 5, but now we're going to be using them with measurements to convert different measurements. So today we are going to be using those conversion factors or those unit rates and the proportion problems that we've been working on. And we are going to be converting units within a measurement system. And I will show you what that means in just a second. So if you have not already done the Spark Your Learning for 6.2, go ahead and pause the video and try this problem out, and then come back when you are finished to see how I thought about it. So Milo is making 1.5 batches of muffins for a bake sale. So I know what he's doing. Each batch of muffins calls for 1 3/4 cups of flour. How much flour does he need? So I know I'm looking for a total. So I know he needs more than this because he's making more than one batch. So I can think about this in several ways. So I know he's making 1.5 batches. So he's not making this last half of the batch. So 1.5. And in this batch it calls for 1 3/4 for the whole thing. And then in this whole thing here, he would need 1 3. This mouse does not like to write threes. 1 3/4. But I know I only want half of this. So I only want half of this. So there are lots of ways I can do this. I could divide this by 2, but I also heard I was saying I want half of this number. And when you want something of another number, that means you're going to multiply. So I'm going to take 1 3/4 and I am going to multiply that by 1/2. This mouse is just really not wanting to write my numbers today. There we go. So I need to make this improper. So 4 times 1 is 4 plus 3 more is 7/4. And I'm going to multiply by 1/2 equals 7/8. Okay. So I know I want 7/8 here, and I want 1 3/4 here. So I'm going to put those together to see how much I want. So I know this part here is 7/8. So if I have 1 3/4, those threes, and I want to add on another 7/8. So right now I have fourths and eighths, and I cannot combine those like they are. So I need to make common denominators, and I know 4 goes into 8. So I'm going to make both of my denominators be over 8. So this one stays the same, so the numerator stays the same. To get from 4 to 8 is times by 2. So 3 times 2 is 6. So I do the same thing to the numerator and the denominator. So 1 plus nothing is 1. 6 plus 7 is 13. And my denominator stays the same because it's still out of 8 pieces. But I can't have a whole number and an improper fraction here. So I know 8 goes into 13 one whole time. And then 8 to 13 is 6. Oh my goodness. Let's see. 8, 9, 10, 11, 12, 13. Sorry, I'm making this video very early in the morning, so my brain is not quite working yet. So here's 5 out of 8. So here's 1 plus 1 is 2 and 5/8. So my total is that they need 2 5/8 cups in order to make the 1.5 batches of brownies. Okay, so make sure you have explained your thinking, and your thinking can be different than mine. That is okay. We think about problems in different ways, and that's how we can learn from each other. So tell me how much he needs, and then explain how multiplying fractions, how is multiplying fractions similar to multiplying whole numbers or decimals? So when you are multiplying fractions, how is that similar to whole numbers and decimals? How is it different? So when you are finished with your Spark Your Learning, go ahead and head over to task 1. Okay, so we are working on converting measurements today and seeing if I have 3 cups, how many quarts is that? Or if I have 20 pounds, how many ounces is that? Things like that. So we're going to be using this measurement table here today to help us. And we won't need all of it for every problem. So we're going to need to read the problem and see which measurements we're using to go and find what we need. So if you do not have a piece of paper, will you please make sure that you have one? So go grab that and I'll get to my first page. So we're going to be coming back to this chart a lot of times today. So problem 1 says that Heather needs the mail package to mail the package shown. The weight on the display is in pounds. So here we know her package weighs 4 pounds. The shipping company, though, charges by ounces. So we know her package is in pounds, but the shipping company is going to charge by ounce. We want to know how many ounces does the package weigh. So we know, so I always like to underline what units am I talking about. So I can see pounds and ounces. So on my table, we're going to, so this is feet and yards. So that's measuring length. Here's pounds and ounces. We are measuring weight. So we need to be using this section here. So I've pulled that over here for us. So I always like to start these problems with what do you know about pounds and ounces? So I'm going to make a row for pounds and I'm going to make a row for ounces. So looking here is where it talks about pounds and ounces. So we know 1 pound is 16 ounces. And you can write this the other way as well. I'll do that down here. I'll put ounces on top and pounds on the bottom. I know that 16 ounces is 1 pound. So either way, we can use these proportion problems and these rates here to help us set up this problem. So I know that 1 pound is 16 ounces, or 16 ounces is a pound. So now we're going to think about what do we need. So this is what we know. What do we need? So down here, it told us we have 4 pounds and we are looking for the ounces. So I know I have 4 pounds. So notice I put pounds all together. It's in my pounds row, which if I did it on this problem would go on the bottom here. And now we're looking for the ounces. We're looking for the ounces. So if you'll remember from module 5, what we are doing is we're going to rewrite these equations so that we can get ounces by itself. So when we do that, so let's take a deeper look at this problem really quick. So let me pull this problem up. So let's take this and let me add that to a new page really quick. So let's take a deeper look here at what we are doing so we know why we can take our shortcut. So if I have this here, I want to get this right here all by itself. I want to know my ounces all alone. So I need to try and get that by itself. So I've got to move it to the other side because I've got to undo this division first. So the opposite of divide is to times. So if I times it here, it cancels it out and we move it to the other side. So now we have ounces times 1/16 equals 4. Now I need to move all of this to the other side, but I can only do one thing at a time. So the opposite of divide by 16 is to times by 16. And that cancels that out, but I have to do it to the other side too. So now I'm left with ounces times 1 equals 4 times 16. So this says times 1. So the opposite of times by 1 is to divide by 1. So if I divide by 1, that cancels it out, but I have to do it to the other side. So now I'm left with ounces all by itself. And I have this problem to do, 4 times 16 over 1. And that will tell me how many ounces are in this proportion here. So let's take a look at the shortcut now. So this is why we can do that, is because we moved everything over by doing its reciprocal, the opposite, and we got ounces all alone. So let's take a look here. When I crisscross multiply these, 4 times 16, that's what I'm doing right here, 4 times 16. And then we're dividing by this leftover number, divide by 1. So this became the same problem as this crisscross, multiply, and divide problem. But that's why we can do it, is because we're just moving everything from side to side, but keeping it the same. So let's come back here and use our shortcut. So 16 times 4 divided by 1 will give us our answer in ounces. Let's try out this bottom problem here. So on this one, I need to get ounces alone. So the opposite of divide by 4 is to times by 4. So if I times by 4 here, because this is 1/4 times 4, it cancels it out, but I have to do it to the other side. So look here, we have 4 times 16 divided by 1. We did the exact same thing and we got ounces all by itself. So when I have 16 over 1 and I want to know how many ounces out of 4 pounds, 16 times 4, I crisscross multiplied, divided by 1. Either way, we are doing the same thing. We're getting ounces by itself. And to do that, we need to multiply 16 and 4, because they were crisscross in either problem, and divide by 1 will tell us how many ounces are in 4 pounds. Okay, so go ahead and pause the video and work on task 1 using this information. So you'll need to make sure you do this problem to get your final answer. So come back when you are ready to do task 2. Hey, so task 2 tells us that in Paris, the sculpture long-term parking created by Armand Fernandez contained 60 cars embedded into 40,000 pounds of concrete. How many tons of concrete are in 40,000 pounds? So here I heard we're looking for tons when we have pounds. So I know the things I'm comparing are tons and pounds. So on our conversion chart here, I'm looking for tons and pounds. Again, these are weights that we use here in America: pounds, tons, ounces. So the first question is always, what do you know about the measurements? So about these measurements, I can see that 1 ton is 2,000 pounds. So I write down what I know. And remember, you can do pounds and tons. Just make sure you line everything up. I can see that 2,000 pounds is 1 ton. So now we need to figure out what do we need to know. So we're looking for how many tons. So I want to know the tons. That's what we're looking for are in 40,000 pounds. So we have 40,000 pounds. So this number up here was just an extra number. There's just 60 cars. It's not asking about the cars. It's asking about the pounds of concrete. So that 60 was just an extra number there. So we can do it the other way here. We're looking for 40,000 pounds. So we're going to put 40,000 matching up with the pounds. We're looking for how many tons. So remember, we're trying to get T all by itself. So the opposite of divide by 40,000 is to multiply by 40,000. And if I do that to both sides, so we're going to times by 40,000 over here, which makes my problem 40,000 times 1. So I would crisscross multiply here. And then we're going to divide by 2,000. So let's try that on the bottom here too. So here's my crisscross numbers. 1 times 40,000, which is what we have here. And then divide by 2,000. Divide by 2,000. So we're looking to get T by itself. To do that, we can crisscross multiply and then divide will reset up that problem for us. So you'll go ahead and use these numbers here to complete task 2. So when you are ready to do task 3, come back and let's work on that. Hey, a bag of flour has a mass of 4.5 kilograms. How many grams are in 4.5 kilograms? So I can hear we are looking for kilograms and grams. And I can see here now that I copied over the wrong chart. This is talking about length, and this is kilometers instead of kilograms. So let's go and look at our chart again. So we're looking for, so this was kilometers, we're looking for kilograms. Oh, this looks like what we are looking for. So I can see that 1 kilogram has 1,000 grams. So let's come back to our problem here. So 1 kilogram has 1,000 grams. Remember, we can set it up the other way as well. And we can say that 1,000 grams is 1 kilogram. So we are looking for the grams. How many grams? So we are looking for the grams. We're looking for the grams. So notice all the grams are lined up. The grams are lined up in either problem are in 4.5 kilograms. So matching up with kilograms, we put 4.5 lined up with our kilograms. So we want to get G all by itself. So I would move this to the other side by doing the reciprocal. So the opposite of divide by 4.5 is to times by 4.5, which means we're doing 4.5 times 1,000 divided by 1. So we are doing 1,000 times 4.5 divided by 1. So don't forget to move your decimal in your problem. Same thing up here. We're crisscross multiplying to get G by itself and dividing by 1. Hey, so use that information to complete task 3 and then come back when you are ready to do task 4. Hey, a camel can drink 25 gallons of water in 10 minutes. How many cups of water can the camel drink in 10 minutes? So our minutes are the same. These are the same, 10 and minutes. So we are looking at gallons and cups. So here I can see cups, but that changes it to ounces. This one is cups to pints, quarts and pints, quarts and cups, gallons and quarts. So this table does not show us the relationship of cups and gallons, but it does show us other relationships here. It tells us that 1 quart is 4 cups, and then it tells us 1 gallon is 4 quarts. So 4 cups makes a quart, 4 quarts makes a gallon. So this quarts matched up here. So kind of looped through. 4 cups makes a quart, 4 quarts makes a gallon. So we went from cups to quarts, quarts to gallons. So we have several things we're needing to do here. So I can hear in our problem that we need cups. We also needed quarts, and then we have to get to gallons. So we're actually going to be setting up several problems here to get to our final answer. So let's start with what we know about cups and quarts. So I'm going to start, and we can see that 4 cups is 1 quart. Always start with what you know about one of them. Now I'm looking for, and I know, let's see here. So 4 quarts is a gallon. So I'm going to say I want to get to 4 quarts. How many cups is that? So we're going to start here with this problem. And we want this 4 here because 4 quarts is 1 gallon. And we're trying to compare cups to gallons. So right now, we don't need this yet, but that's why we put a 4 here, is because 4 quarts is 1 gallon. So let's find C by itself. So the opposite of divide by 4 is to times by 4. So 4 times 4 is 16. Divided by 1 is still 16. So that means there are 16, these all match up in this row here, this column, 16 cups, 4 quarts, 1 gallon are all the exact same amount. So now I can compare cups and gallons. So this is what I know. 16 cups is 1 gallon. And now let's come back to our question. The camel drinks 25 gallons. So 25 gallons, matched it up. How many cups? So we want to get cups by itself. So the opposite of divide by 25 is to times by 25 and then divide by 1. Okay, so you'll go ahead and do that problem there for task 4. So just remember, if you can't find it on your chart, you just might have to find from this one to the next one and then use that information to figure out your answer. So you might have to do 2 problems to get where you're headed. Okay, so go ahead and do task 4 here today. And then make sure when you are done with task 4 that you go back and click I'm done in Ed and then do your check for understanding today. Okay, let me know if there is anything I can do to help you.